Okay, hello everybody. So thanks to the organizers for the kind invitation. It is clear from the program this morning that the profusion of data in healthcare has generated lots of expectations and also some anxiety. So I'm on the side of processing the data, and as a researcher in machine learning and applied mathematics, I would like to share with you my perspectives and share my experience on these questions, and that comes also from other experiences in other fields, other industrial applications. So first of all, I would like to, first of all, I imagine that all of you are convinced that healthcare will be deeply transformed in the next years and decades, and it will turn essentially to a completely digitalized form. When mentioning the digitalization of society in general, in fact, it's all about sensors, data, and algorithms that will process the data. So I will, sorry for the, so the question is that since most of the ingredients are already here, why does these ideas come now in the field of healthcare? So of course there is the availability of cheap sensors and non so intrusive sensors, the capacity of course of storage that has exploded in the last years, but also there is maybe more pressure from the society. So the aging of the population, the economic crisis maybe put more pressure on both governments and institutions that have to deal with these issues. And so there is now, I think, lots of thinking and initiatives that try to take advantage of both the technology and the science that has been developed and algorithms that have been developed in the last 20 years to maybe take advantage of all these elements in order to provide some new applications, new products, new services to society. So in this talk I want to first give you a flavor of the kind of projects I'm involved in. So these projects are due to my influential meeting with Professor Pierre-Paul Vidal, who gave a talk yesterday. So maybe you can see this as a companion talk of his talk. Then I will just illustrate some ideas about the power and limitations of machine learning methods. And in the end, I will maybe give some more speculative ideas that have to do with how, let's say, many sectors of activity, many communities have to be reconfigured in order to really make significant advances in this program of digitalizing healthcare. So first of all, I want just to give you some very short illustration, and it's mainly to give you some insights about the philosophy we have in running these research projects. So the idea is to start with some very simple clinical tests that neurologists and ENT clinicians and rehabilitation clinicians do every day. And quite systematically, but they do it only providing the judgment of their eye. And we intended to digitalize these exercises and these evaluations. And the idea is to have, using very simple devices that are easy to use in the consultation, and also that are compatible with the ergonomy of the consultation. And the idea is, of course, to build large databases and see what we can extract out of this data. So, the purpose of this work has maybe 3 different levels. So the object of the research is mainly behavior, and based on only low-level measurements from the sensors, the type of sensors I mentioned before. And we do not really rely on questionnaires or assessment from the clinicians. Of course, they can be used as additional information, but at the first step, we would like to see what just observing the behavior can tell us. So the different levels of contributions are first, of course, descriptive, because we can provide a quantified assessment of what the clinician sees during the examination of the patient, and also it gives him some ability to perform some longitudinal assessment that is kind of objective. And also he can position his patient thanks to these summaries of the measurements, comparing him to the whole population of patients he has he's seeing, and maybe also he can confront to other to patients from other doctors. Another level is the predictive part. So the idea is, of course, experts in posturography don't believe this, but actually nobody really did the experience. The question is whether you are able to predict, for instance, the fall for elderly patients just by observing his measurements in terms of balance and walks and maybe some other aspects of his motion capabilities. So this is one open question, and we think we will answer very quick to this question. Since we have already probably one of the largest databases on posture right now with this ongoing clinical trials at Hôpital de Val-de-Grâce. And we can also think about indexes, and maybe similar to the one evoked in the previous talk, and maybe that will reflect the evolution of a pathology over time. The third aspect is maybe more about the knowledge management part, because collecting all this data and maybe plugging in tools that are very common for domestic use, such as recommender systems, search engines, we think that also it can help the specialists to better assess therapies, and also to maybe explore the results of a clinical examination in a different way, maybe sharing with, in a different way, his findings, and comparing them, exploring these databases in a really completely novel type of interaction. So these are the 3 levels we are currently interested in around some specific actions. And one very important aspect that may provoke false expectations from the big data buzz is that our experience is that in order to take advantage of all this data, it is very important to have a significant cohort size, but especially it is very important to control the context of data acquisition. So that is, so in order to have relevant conclusions, it's very important to control the protocols of collecting the data. So there are these different bricks in our work. So of course the choice of sensors and how you position them, the databases that are fed with the data coming from the sensors. There is all this intelligent part of algorithms that will organize, structure, and summarize the data. and extract the information. And also there is another level, which is the type of interfaces to allow the man-data interaction. That also, all this question of data visualization is also a big topic currently in scientific communities. So among the possible the potential for tools and functionalities coming from this this integration of different tools is, of course, some were mentioned in the previous talks, like monitoring the patients, the follow-up, but also making recommendations to the specialists. Also for training, it can be interesting, and for scientific discovery. This is what is observed in many different fields. So the working assumptions in our work are that first there are many things about the genomics, molecular biology, what is happening inside the body, but in the end there are not so many things known from a clinical perspective on the human phenotype. And all the devices that are now available in the wearable technologies and the quantified self-technologies, they provide a means to collecting information and starting thinking about this in more detail. Another aspect that maybe limits the capacity to statistically aggregate information is that probably every human being is very different from the other, but at the same time, each human being is very stable in time. So that's maybe where potentially the most interesting findings will come out from. And the other aspect of this, the other perspective we have is to consider the human body as a machine like any other machine. So a few words about the machine learning methods. So probably some of you are already familiar. I will not give you technical details, although we've done a lot of realization on particular algorithms for classification, scoring, ranking, high-dimensional data and complex data. But it's more to give you an idea of what can be expected and maybe what cannot be expected, or what make problems really difficult for algorithms. So first of all, machine learning is now everywhere. It's at really the you have lots of technology that rely on this mathematical and algorithmic techniques. They are already embarked in many mobile technologies for instance, for display that learn your preferences. So you have many such functionalities on your mobile phone. Among the most successful are, for instance, the ad display that are performed through real-time bidding technologies that really are able to target very, well, not so accurately, but accurately enough so that people make a lot of money out of it. You have many other intelligent algorithms that, for instance, screen your emails, and also another interesting application of machine learning is language translation, for instance, that now completely relies on scanning text and comparing patterns rather than just trying to find correspondences between words or sequences of words in dictionaries. So these are some examples that are already very, very developed and very efficient. And there are lots of also embedded machine learning technologies for domestic uses. So the probably most efficient are the search engines and the recommender systems. Also in pattern recognitions, the zip codes are read automatically in the US, in the postal services. And also in fraud detection, there are lots of algorithms that try to protect your transactions from fraudulous behaviors. So the machine learning, well, there are some very, let's say, simple applications that just make smart your interaction with a mobile, but in some cases they also emulate the human behavior, and they help in organizing large databases, but where they are probably the most efficient is in leading to reliable prediction on some stable and regular phenomena. So I want now to give you some more details on a particular cognitive task, which is recognizing objects or patterns. One very classical example on which many teams over the world have challenged their methods is the handwritten digit recognition. So this is a task that humans perform with, if we consider a classification rate of the order of 99.8%. And currently there are algorithms that really perform very well on this task, really close to human performance. And there is another problem which is very simple for us, which is if I give you an image, are you able to say if there is a cat in the image? So this is called the cat detection problem, and there have been some papers on this problem, and actually it's a really difficult task. So if you are interested in checking the results and the methodologies in more detail, there is a web page that is maintained by some very well-known machine learning scientists from different companies that are leading companies, of course, in the field of internet. And also there is a research paper on the cat detection problem published in Journal of Machine Learning Research by Don Guillemin and François Fleuret in 2008 that really has an interesting, presents an interesting method to perform cat detection. So it is clear from this work, and well, if you think about it, you will see that it's much more difficult actually to find the cat in the image, which is maybe the task that is easier for the human eye. And this is due to the diversity of contexts in which you can capture cats in these images. And actually the work by Guillemin and Fleuret is relying on learning not only the form or the, let's say, the shape of the cat, but also the pose. So that gives some idea on the aspect of the body of the cat that has to be incorporated in the algorithm in order to reach a reasonable performance, which is of the order of, let's say, for a rate of true positive detection, it's about 5% of false positive, which is a decent performance, but clearly very far from the human performance. Now, more advanced applications of machine learning that can be designed for expert use are, for instance, the search engine application. And we did that in the field of aircraft, anomaly detections for the aeronautic industry. And the motivation for this project started from the discussions with the vibration engineers that are, after testing an engine, they collect some signals and they represent them in a frequency domain. These are these periodograms you can see. I don't know if you can see them very well, but they are really very ugly images that are really difficult to analyze. And they were scrutating these images for hours in order to find potential anomalies. And the idea was maybe to help them in identifying maybe anomalous parts of the image, and especially they were interested in a tool that would that would compare these really tiny details with the images they have collected in the past. And of course, if these engineers, some of them have a lot of experience, so they've been working for 20 years on aircraft engines, and they are able to really, just by looking at that, they can say, okay, I've seen this detail on this engine that I analyzed maybe 15 years ago. And but this expertise is, it takes some time to train a vibration engineer in this spirit, and also it's not that objective. So the idea was to consider maybe a part of the image as a query, and then scan the database to find similar patterns that were present in images presenting the same features. So in this example, you can see the query on the top left image, and then they are ranked from left to right and line by line, starting from the top. So you have rank 1, the most similar image to the query, and then the second, the third, up to the eighth rank image in the database. So actually, it was quite a difficult problem because you see that it's really a very noisy signal, and it's let's say the feature that makes these images similar is also a very tiny part of the image. Okay, so there was a question of first finding what is a relevant description of such an image. Clearly, if you take just the image as a matrix of pixels, that is the approach taken for the handwritten character recognition. You don't really need to pre-process the image and extract some geometric features, and it works really well. But here, if you do this, there is no hope of categorizing properly such images. So there was a first step, that is to really understand what is the right representation, and then of course defining a metric that will allow to compare different images and to rank them. Okay, so there are all these very customized and specialized aspects of the analysis to develop a search engine that is really dedicated to this kind of use. So, so here context is really, really important. And of course, there are very valuable benefits from this work. That first, there is some kind of anomaly score that is deduced from the metric that was introduced, and it allows a very fast screening of the database. It is replicable, objective, and it's a fantastic tool for training people. So that's much more efficient than what people did before. So this is just to give you some thoughts for possible extensions of these ideas to issues that are encountered by professionals in the field of healthcare. And now I would like to give you maybe some ideas that are quite general, but that maybe show some difficulties in proceeding further with this type of work, especially in healthcare. So first, there is this idea of capturing the context, which is not always easy. And from my experience, I've met many clinicians that said, okay, you have fantastic mathematical methods and fantastic algorithms. I will give you my data and you will, revolutionize my field. But it never worked, okay? So it started working once I participated to the definition of how we collect the data and how we structure them, and having in mind what can be done with this data. Okay, so having some kind of Taylorist approach is probably not the right direction. And also considering maybe the statisticians or biostatisticians just as the technical guys is also not probably a good approach. So I think we have very nice results now since we have our own data, and we are really working on this in very close collaboration with clinicians and experts of neurophysiology. Then we need some tools. So as I said, there are many tools available. Everything is here, basically. Okay, all the tools you need, in terms of concepts and algorithms, are already there. But there is a problem that is how you use them and whether you can adapt them to your needs. And there is a problem because I think it was also mentioned in a previous talk, but they are not always validated, actually. They are, all these methods, they are published on paper. And there are some, in the papers you can read some results from numerical experiments, and there are classical benchmarks that people will use and compare their methods to the previous ones. But the only criteria to publish are, well, whether it's a new method, is it technical enough? Does it look, difficult enough to understand? Is it simple methods are not very popular, but in scientific publications, and also whether they improve existing results. So that's maybe not the only criteria to use if we think about applications and about real-life applications. Another, there are also other issues related to this that were also discussed in a past edition of The Economist that had a really nice series of articles criticizing the practices of scientific communities who publish results that are not always very objectively evaluated. And as a member of this community, I confirm that this is not the case. And also that the previous criteria used for publishing also in fact have provoked a drop in the publication of negative results, and this mechanically increases the rate of false positive among the published results. Okay, so this is also some kind of bias in the understanding of a phenomenon, what is true and what is not true, that also has to be kept in mind. So my vision is science as we know it is probably over, and it will be soon the case in, maybe it will be a different expiration date depending on the field, but this is my impression from what I can see. But there is maybe another kind of science that has not been developed at let's say significant proportion, and it would be a science that in which actually the methods proposed would be evaluated online on data submitted by the end users or the evaluators, and these algorithms would have to run independently of anything else. So they will be peer reviewed, of course, but also the implementation can be peer reviewed. Okay, so this encourages a different approach of scientific publications that imposes the implementations to be open and validated by the experts, and they can be proposed, of course, in a specific context in order to have some relevant results. And actually this was done in my lab by a colleague of mine, Jean-Michel Morel, in the field of image processing. So he's really an expert of the field, but he realized a few years ago that he had no idea of what was the state of the art in image processing, although he was working 20 years in image processing. But there were so many publications and everyone claiming that, okay, we are the best. And every time he would face the demand of an industrial partner bringing his own images, he would have to start from the beginning. So new PhD student and everything from the start. Okay, so he proposed to have this online publication of algorithms that are peer-reviewed, so it's like an online journal. And what is assessed here, it's not the novelty, it's not the technicality, it's only the fact that the algorithm, that is the implementation of the algorithm, is exactly the same as what is described on paper, and the requirement is to have an online the capacity to deliver online in a few seconds some result. So also this imposes to have almost no tuning of parameters, which is, you know, placing the let's say the acceptation level pretty high. Okay, so there are also other aspects that have to be involved that are more in, let's say, the sociology of collaboration, and also I think the profiles of people involved have to probably be different. So we need to train, you know, clinicians that can be at the same time engineers or the other way around, and also the scientists should probably become, you know, more interested in the implementation of what they propose, and the implementation I mentioned is some kind of industrial version of their methods that can be replicated and that can be scalable. Also, the way you promote products that could derive from these developments should be also probably be imagined in a different way, so make it more open. So the also sharing the data is important. So this was also the topic of previous talks, and it's I think the only way to really observe significant improvements in taking the best of the existing technologies of data that are in the present situation very fragmented, as we can see in the hospitals, for instance. Okay, so I think I need to finish the talk. So this was also mentioned this morning by the representative of Sanofi, that it's important to instead of raising walls, to try to introduce interactions between different fields and different divisions in companies, and also different scientific activities, and this can be done only with tools. So the example I gave of IPOL, this platform for online experimentation of image processing algorithms, is exactly the kind of tools that can answer this kind of expectation. And some food for thought that are maybe more questions for the society, and but that can also be some barriers for now for further use of data and developments of these machine learning methods in the field of healthcare. So I'm ready to answer some questions, except if you have more thought for food than food for thought. So thank you very much.